Welcome to In 5 Minutes. In this video clip, we will discuss what is a white noise. We have discussed various sources of noise. The two major categories are external noise and internal noise. External noise is further divided into natural noise and man-made noise, and internal noise is due to variety of internal sources. We have discussed sources like thermal noise, partition noise, short noise, low frequency noise, high frequency noise, etc. Let us try to understand what is a white noise. White noise is not a specific source of noise, but it is just one property, or it is just one type of noise. For every signal, we can define something called as power spectral density. Power spectral density gives us a function of power. It is nothing but a function of power with respect to frequency. So if I know the PSD of a signal, then PSD will be nothing but a function of frequency of the signal. So if I put any frequency value in that particular power spectral density, I will get the amount of power of that particular signal. So for example, if I put f equal to 1 kilohertz in the expression of power spectral density, and let's say I get the value of P equal to 10 raised to minus 2 watt, that means the power present in the signal at 1 kilohertz is 10 raised to minus 2. If I put f equal to, let's say, 2 kilohertz, and if I now get the value of power as let's say, for example, 10 raised to minus 1, that means the power in the signal at f equal to 2 kilohertz has increased to 10 raised to minus 1 watt. Suppose if I put f equal to 3 kilohertz, and if the power value becomes 0, that means the power at 3 kilohertz is 0. In simple words, 3 kilohertz is absent in the signal. So power spectral density gives us the amount of power at various frequencies in my signal. So for example, if I plot power spectral density versus frequency for certain signal, and let's say the plot comes out to be something like that, this means the signal contains frequencies from f1 to f2. All the frequencies outside this range are absent because the corresponding power is 0, and hence the bandwidth of the signal can be defined to be f2 minus f1. So power spectral density gives us the information on power content at various frequencies in the signal, which will further tell us which frequencies are present and which are not present. You can also make one more conclusion, that frequencies in this particular band are more dominating compared to frequencies towards f1 and f2. So now let us discuss what is a white noise. A white noise is nothing but a noise which has got flat or constant power spectral density. So if I draw power spectral density of white noise, we draw two-sided power spectral density. So power spectral density is nothing but function of frequency. Then we get a flat line, a constant line. So this simply means that you put any value of the frequency, DC 0 Hz, 1K, 2K, 100K, 1 megahertz, minus 1K, minus 2K. This is two-sided representation. So we are plotting PSD with respect to positive as well as negative frequencies. So whatever value of frequency you put, you get the constant power. Now let me use the notation of this value as n0 by 2. So the power spectral density of white noise, which is a constant, and that constant value we are calling it n0 by 2. So n0 by 2 is nothing but the PSD of a noise, and because it's a constant, we call it PSD of white noise.